Let's now spend some time focusing on the Linux rescue environment provided with RH5. This is an environment which allows you to recover from problems related to booting your operating system, perhaps related to the grub environment, as well as file systems, as well as other types of errors that prevent your system from booting successfully. In addition, you can use a rescue environment to reset root's password, or any user account's password for that matter, in the event that you've forgotten a user's password. Generally, you will use it to reset root's password as opposed to other users' passwords. Now, we're using our VMware instance for this particular session as the physical system isn't required. This system's up and running in run level number 3. You can tell because it's in text-based mode. We'll log in as root and then execute a run level, which will tell us the current run level, which is run level 3. Whenever you see an N in the first column to the left of the current run level, it indicates that the previous run level is unknown, which means we booted directly into run level number 3. Whereas had we been in, let's say, run level 5 or 1, then those numbers, 5 or 1, would be specified in place of the N. So with that said, we're currently in 3. We're going to reboot the system into rescue mode and reset root's password. Although we know it, we haven't forgotten it, but we'll simulate having forgotten root's password. Now we'll need to ensure that we can boot from either the first CD of 5, the DVD, or the boot ISO CD. Either of those CDs or DVDs will allow you to boot the system in rescue mode. We'll also need to ensure that the VMware instance is set to allow the media, the bootable media, to the CD-ROM or DVD to be booted. So let's go ahead and execute reboot, and we'll interrupt the startup process by pressing F2 when it comes up, as you typically would do on a PC system, either executing F2, F12, F1, perhaps escape, or the delete key. So all the services are being shut. We'll see the VMware startup menu momentarily. And the file systems are being unmounted. And now we can interrupt the startup process. Then let's navigate over to boot and ensure that CD-ROM is atop the list by pressing the plus sign. Now the CD-ROM will boot. We have already placed into the drive, the CD-ROM drive, that is, the boot ISO CD. So we'll be presented with the menu momentarily. So here's the main menu. Now, again, we're going to simulate that we have forgotten root's password. And to do so, we'll execute Linux space rescue. This will propel us into rescue mode. Optionally, to reset a password for the user root, you can launch into single user mode. Linux rescue or single user mode will do. Let's go ahead and execute Linux rescue. This will boot the process, which includes a step which prompts us to indicate where where the installer can find, or the rescue environment can find, the source tree that was used to set up the system. So if you install your system using HTTP, FTP, NFS, or local media, have that source available. In our case, we installed the system using the network, so we'll reference the network using HTTP, although it is available using FTP as well. So it boots as if it's going to set up the system, but it prompts us for the language of the environment, the keyboard type, and then for where the source files can be found. We'll go ahead and indicate HTTP. Now, if you boot from a local CD-ROM or DVD drive, or DVD that is, then you can just indicate local CD-ROM, as you will have all of the media available locally. However, if you have the media or the RPM files or the source tree available on the wire, then specify a network protocol which will give you access to the source tree across the wire. IPv4 and 6 support is enabled by default, and now an IP address will be requested from the DHCP server, and just like when we're setting up the server, we need to indicate the IP address followed by the path to the source tree. So the IP address of the server is what we've just indicated, and the path is /RH5/I386. This is where the source tree can be found using the HTTP protocol. As you can see, stage 2 of grub is being retrieved, and the rescue environment will search the hard drive for a Linux installation. Once found, it will mount the Linux installation beneath /MNT/sysimage. So we'll find or gain access to the file system beneath mount sysimage. However, if we need to interact with the files using commands like nano or editors or programs that are common to a normally functional Linux system, then we'll want to change root the environment, changing the top level directory from /MNT/sysimage to simply /, and there's a command to assist you with doing so, and that's the change root or chroot command, which changes the root to whatever you specify. So let's go ahead. Now you also have the option to mount the file system in read-only mode in the event that you don't want to affect any changes to the file system. So the option's there, and you may also skip the process altogether of mounting your file system, which will propel you into a shell, which will allow you to interact with the system. It will allow you to run fdisk, for example, to enumerate the disks connected to the system, and to optionally mount any of the partitions that are configured on your disks. So let's continue. This begins a search of mount points and file systems to mount. And once found, the rescue environment tells you that it's mounted the file system beneath mount or MNT sysimage. However, if you would like to make that mount sysimage directory the root of your file system, you'll need to use the change root or chroot command. Now we're at the shell. This is a single user shell. If we execute df-h for human readable format, you'll see that all of the mount points that we configured during the installation of this VMware instance of Red Hat Enterprise Linux are made available beneath the following mount points. Sysimage represents the SDA2 partition, which represents the root of the file system. Home, var, boot, and dev. If we navigate to MNT sysimage, we'll find the root of the file system, and ditto for the other mount points such as var, home, and boot. So with that said, we now have access to the file system in rescue mode. Again, we're simulating, in this particular case, the inability to access the system as root because we've forgotten the password. Now, if you want to change the password for a user, execute password. However, you need to indicate the name or the user ID, so password for root, for example. Now notice it says unknown UID 0. Doesn't know who I'm talking about. Let's go ahead and change root MNT sysimage. Now when we execute df-h, you'll see that the file systems have been mounted in a more familiar fashion. This is what we're accustomed to seeing when the system's up and running, when it's fully functional, whereas MNT sysimage reflects what we see during installation when we go to one of the available consoles, Control-Alt F1 through F5. So now we see a familiar setup. / is bound to SDA2, home, SDA5, so on and so forth. Let's go ahead and execute the password command, and now you see that it works because the appropriate directory structure from the root on down is in place. With that said, we'll indicate a new password. And now the password for the user root has been updated. Super. So that's how you would fix the password issue in the event that you've forgotten it. That's one way to do it. Boot your system using the rescue environment. Have the rescue environment find the file systems and propel you into single user mode. Optionally, reboot your system and interrogate the boot menu, the grub boot menu, by appending the single option to the end as we've done multiple times after installations. That will also propel you into single user mode without prompting you for authentication, at which point you can change the password of the root user or any user for that matter, and it avoids the step of having to execute change root followed by mount sysimage. Super. Now what about other boot problems? This is a simple, or this is in fact not a boot problem, this is just an administrative issue related to passwords. How about for real boot problems, such as grub's inability to boot the system? So supposing we alter the environment such that grub's unable to boot. Let's go ahead and do it since we're in a single user mode. We did mention that beneath etc there's a symlink for grub.conf, which points us back to boot grub.conf. We can modify the symlink, which will simply open the source file. Now supposing we want to change either the partition or the hard drive or both that grub is instructed to load the root file system from. Here it is. HD0 translates to dev SDA for our system. 0 translates to the first partition. Let's just look at that from the shell again. df-h. The boot file system is SDA1. That's the boot file system, boot mount point, whatever you want to call it. SDA1 translates to 0, the second 0 that you see in grub terminology. HD0 translates to SDA. So SDA is the first SCSI or SATA hard drive. HDA is the first ATAPI or IDE hard drive. So HDA / or comma SDA is equal to HD0, the first hard drive, whereas HDA1 or SDA1 is equal to HD0, comma 0, indicating the first hard drive, the first partition. So our system boots from the first hard drive, the first partition, which is this /boot mount point, which contains the Linux kernel, among other things, of course, including grub, the initialization, RAM disk file or image, and other items. So what if we were to make a change that prevents grub from booting the system? Let's nano grub.conf. We'll change the hard drive, and this is something you could face on the exam, for example, where grub is unable to boot your system and you need to be able to determine what the problem is and rectify it. Again, this is a perfect usage of the rescue environment. Grub's unable to boot, so you need a way to get your system up and running and fix the boot environment. And this is only one way to do it. Another way to do it is to use grub's command to update the master boot record in the case that grub doesn't boot altogether. If some other bootloader or some other operating system has wiped out your master boot record, grub provides a facility to rewrite the MBR. But in this case, we haven't lost our master boot record. We've simply changed the default hard drive that grub uses from the first to the second. So with that said, let's save the changes and reboot the system. Now we'll need to change the default boot device to the hard drive from the CD-ROM. So let's F2 to get into the BIOS. Otherwise, the CD-ROM will boot, and then we'll use the plus sign to, or the minus sign to move it down, and the hard drive will become second. Then we'll exit, saving the changes, and this will boot us to the main menu. Now there's the main menu. Now it's going to attempt to boot the system. Notice it throws an error. Booting Red Hat Enterprise Linux from root HD1 from the second hard drive first partition. Selected disk does not exist. So not only does the partition not exist, the disk doesn't exist. And if you press any key to continue, it returns you to the main menu. If you attempt to boot, it just keeps looping because it's unable to find the first hard drive first partition, or the second hard drive, that is, first partition. It really should be looking for the first hard drive first partition, or HD0, comma 0. So it's important after you've set up your system to note the default boot hard drive and partition as far as grub is concerned, HD0, comma 0, wherever you happen to have it installed. So how do we rectify this issue? Well, there are multiple ways to address it. You can reboot the system and launch yourself into single user mode using the rescue system, which takes a little more effort, or you can simply edit the grub menu. Now in order to edit the grub menu that's password protected, you need to first press P, indicated by the menu. It prompts you for the password, and so long as you have authenticated or provided the proper password, you'll then be able to edit the grub entry. We've all along modified the second entry, the kernel entry, and we've also instructed you or advised you not to modify the first entry. But in this case, grub's unable to boot your operating system. So we have no choice but to edit the first entry, changing it from HD1 to HD0. We'll press enter, and this will update the grub boot menu, but it doesn't commit the changes to your hard drive. This is simply for this boot or this instance of booting your system. So keep that in mind. This is not a permanent change. This is a temporary change to allow you to boot the system for this time and this time only. The kernel line looks fine. It launches the kernel from boot VM-Linux, the version, read-only. The root uses label 1, which is referenced in the etc file system table file, fstab, with a few kernel options, or a couple kernel options. So this will boot our system into run level 3. However, if we wanted to quickly, permanently fix the problem, we could boot into single user mode, update the grub.conf file, and then reboot the system. But let's just prove that this will work. We'll go ahead and press B to boot, and this will boot us directly into run level 3. Notice now there are no errors. The root, or the boot file system, which is located on the root drive HD00, has been located. The file system type is ext2, and the initial RAM disk has been set up, and it gets unloaded after the root file system has been set up. So this is working as expected, but again, when we reboot the system, it's going to attempt to launch from the wrong hard drive, from the second versus the first. So this is looking good. So again, once we're up in level 3, we can then use the nano editor to modify etcgrub.conf. And this is coming up exactly as we've expected. Again, this is only one of multiple problems that could be presented to you in a production environment or on the exam. The inability to boot your system, and you need to determine whether or not it's a driver, a service, or perhaps grub that's protecting you, or preventing you, that is, from booting your system. You can tell if it's grub because when you try to boot from the main menu, it'll throw an error, indicating, for example, the inability to find the hard drive. So let's log in and confirm that the settings were not committed to the hard drive. We'll modify etcgrub.conf, which is similar to /boot/grub.conf, and notice that the default hard drive. Now for the splash image was loaded successfully. If we change this, it would fail as well. The default hard drive for the root, as far as grub is concerned, which is really the boot file system where the kernel can be found. Again, grub is a bootloader that works with multiple operating systems, including Linux, but not limited to Linux, including Solaris and others. Even Windows can be booted from grub. So let's set this to HD 0,0, and this will rectify our problem for this particular instance. And other things could be changed. For example, the name of your kernel could be changed. So the right hard drive may be found. Let's add an extra Z here to throw off the kernel, or the name of the kernel. We'll reboot the system, and we'll be presented with the grub menu momentarily. So again, these are just some of the bugs you may run into, either in a prod environment or on the exam. Now in a prod environment, you shouldn't see these sorts of problems often. If you do, they should reek of tampering or unauthorized access. In a prod environment, it should be controlled, and unless an administrator has made a grave mistake, you should seldom to never see this sort of problem. So now the system's being rebooted. We don't need the boot CD-ROM at this particular stage. We'll see what happens when grub tries to boot the operating system using an incorrect kernel name. Notice, file not found, VM-Linux with an extra Z. That's exactly what we expected. We can try it again, it'll fail. So let's enter P and then specify the password and then edit the grub menu. We can edit this entry by pressing E, navigate over to VM-Linux, and drop one of the Z's. In addition, if we would like to fix this problem quickly, let's launch ourselves into single user mode. We'll B to boot, and the same goes for the initial RAM disk. If it has been misnamed or the file doesn't exist, or let's say the file has been renamed in the boot partition, when grub attempts to set up the initrd, it'll fail. So any of the three entries that you see on the grub menu could prevent you from booting in the event that they're indicated incorrectly. So now we're coming up as expected, but it'll be an abbreviated boot. So be as familiar as possible with the grub startup environment. It needs a default hard drive and partition, usually an initial RAM disk, and a location of the kernel. Any of those three items could be off, preventing you from booting. So with that said, let's fix the problem. We'll nano etcgrub.conf, and drop the extra Z in VM Linux, and this will allow us to boot. However, how about the initRD? Instead of changing the name in grub.conf, let's navigate to boot and change the name of the file on the file system. We'll move initRD to initRD.corrupt. We'll then reboot the system to see how it behaves. It tells us it's better to execute shutdown instead of reboot from the command line. In either case, we don't have much open, and there are no connected users since this is single user mode. So we'll be back to the main menu momentarily. Again, these are all items that are likely to come up in various environments. So, after 5 seconds, this attempts to boot. Notice it can't find the initial RAM disk. Exactly what we expected. We'll try again. It's going to fail. initRD was not found. So again, if you know the name of the initRD, specify. But if for some reason it slipped your memory, that's where the Linux Rescue Disk can help you. Because at least with the Linux Rescue Disk, you can boot into a single user mode environment because it sets up the initRD as well as a proper kernel or a functional kernel and provides you with access to your file system. So again, you may not remember the name of the initRD, but however, at least Grub provides you with an environment so that you can do some investigation. So for example, an EDA edit, the first thing you check is the root hard drive. It usually is 00 on most systems. Then you check your kernel. Does anything look funny with the name of the kernel? You may have other Red Hat systems in your environment. Compare and contrast. Chances are they're running the same enterprise version, so they should have the same kernel version, or be named similarly. VM Linux, 2.6b main, 18 minor, with any changes made by Red Hat. And here we see the initRD. Now we could specify initRD with the corrupt image name. For example, let's edit this entry and append corrupt. Then we'll launch into single user mode by modifying the VM Linux or kernel line and see how it boots. We'll then press B to boot, as indicated in the documentation below. B to boot a particular entry. And notice, although the file has a suffix of .corrupt, it still launches. This tells us that Linux truly has no regards or care or concern for suffixes. In other words, suffixes don't mean much, doesn't mean as much as they do within a Windows environment. In Windows, a suffix is everything because they're file associations. In Linux, it doesn't mean anything. So long as you have the appropriate file and it does what it's supposed to do, then the system will continue to function. So we'll be up in single user mode, at which point we will rename the file, dropping the .corrupt suffix. So let's navigate to boot, and there we see the initRD image. Let's move it, dropping the corrupt suffix. But then of course it makes sense to navigate into grub and modify the grub.conf file, changing the .corrupt. Now, in this case we don't have to, so we even threw myself off. We don't have to because we made a temporary change from the menu, so there's nothing to change, which is a good thing. So this works well. Now let's reboot the system and make one other change, one other semi-detrimental change. We're going to rename the file system table file, fstab, which is beneath etc. Now the etc subdirectory or etc tree contains primarily configuration files, one of which is the fstab or file system table file. That file houses the translations between mount points and dev tree specifications. So for example, the fact that the root file system is the dev SDA2 partition is translated and maintained within the etcfstab file. Ditto for /boot, var, home, dev, swap, and any other mount point that you may have on your system that is automatically set up when your system starts. That's all handled by the fstab file. And one difficulty you might experience either in a production environment or on the exam is a clobbered or corrupted or removed fstab file. So we'll be out momentarily. We're entering on level number 3, at which point we will have access to the primary console. the TTY1 console. By the way, each of the TTYs are labeled or numbered accordingly. So the first console is TTY1, second TTY2, all the way through TTY6, and the seventh console is the graphical console in the event that you have an X environment set up. So we should be up momentarily. Now the next thing that we're going to do, FSTab, is truly going to give us a headache. It's going to clobber the system. So let's go ahead and log in as root. We're up and running in the run level that we want to be in. And then we'll navigate to etc. Now again, this FSTab file that we've been talking about contains translations between the partitions and their mount points. So root, for example, and of course their file system types and any options that are to be applied. Home, var, boot, any dev items, such as the sudo terminal and temp fs, sysfs, proc, which is a special file system, and a swap file system. So FSTab is a really important file. Now rather than changing a single entry, let's move FSTab to fstab.corrupt. This will throw all sorts of errors when we try to boot the system, causing us to have to enter a rescue mode. So we'll reboot once more this server, this VMware server instance, and you'll see the errors that are thrown. Now the errors will eventually cause us, and notice that we're unable to, the shutdown is even throwing, or the reboot is throwing errors. This will inevitably kick us out of the VMware instance, causing us to power it up, change the BIOS to boot the CD-ROM, and then launch the rescue mode. And even the rescue mode will be unable to find any Linux partitions because the rescue mode searches the accessible hard drives for an FSTab file. So now it's going to boot within 5 seconds, down to 1, and now it's going to try to boot, and all will look well because the boot file system is accessible. Grub knows where to find the boot file system. It has a driver for ext2 as well as for other file system types such as Riser. So it knows how to get to the file system, at least where boot is concerned, /boot, which contains the Linux kernel, the initial RAM disk, the grub menu, the stage 1, 1.5, and 2 drivers. So far so good. However, once init has been consulted, which grub hands off to, init's job is to set up the runtime environment for the desired run level, in this case, run level 3. And now you see all the different errors that are being thrown, because certain things cannot be accessed. etc, sysinit, which gets called from init tab. You know this is definitely init tab. We saw it when we looked at the init section, and all sorts of errors are being thrown. At this stage, syslog is attempting to start. It's going to throw an error, and eventually we will be kicked out of this environment, and we'll rectify it by booting into the rescue mode and manually fixing things. Again, this is something you may experience on the exam or in a production environment. A corrupted FSTab file. Perhaps an administrator clobbered it using output redirection, or inadvertently renamed it or removed it altogether. Again, anyone with root level access to the system can inadvertently or purposely clobber key startup files, which is why it's imperative that you back up your system as often as possible, in particular the key startup files. But there's always a rescue environment, and there's also the emergency environment. The difference with the emergency environment is that init is not loaded. In the event that you experience problems starting a rescue environment, you can always type Linux space emergency at the start menu or the installer menu of the boot ISO CD-ROM, first DVD, or first CD, and you will then be able to enter into a limited environment, a single user shell without init, at which point you can use utilities like fdisk to enumerate the connected disks and attempt to mount whatever file systems are available and recover whatever data is recoverable. So this will kick us out momentarily. There isn't much we can do at this stage. We can press a few keys, enter. Syslog is attempting to start, but it will eventually give up, causing us to have to repower on the system. So now we've been kicked out. Let's power on this virtual machine and interact with the boot up process to get into the BIOS, and then we'll enable the CD-ROM as a default device and propel ourselves into the rescue environment. We'll go ahead and execute Linux Rescue and walk through the process of attempting to rescue the system. Again, in this mode, when FSTab is missing, you'll see that RH5 will be unable to find any Red Hat Enterprise installations, which means we'll have to manually mount the file systems that we're interested in rectifying. Now, since we have a sense that FSTab's missing, because we saw in the boot up screen the inability to load different file systems, we know we want the file system that contains ETC. And since ETC is not a standalone file system, it means it belongs to the root file system. So we really need to focus on wherever root happens to be. And that's / not /boot, but /. So that'll be the SDA2 partition. Let's indicate where we can find the source tree using the HTTP protocol. Stage 2 will be loaded, and momentarily we'll be presented with the ability to work with the single user environment. So this will attempt to find Red Hat installations, and notice it tells us we don't have any Linux partitions, although we do. Now we have a single user shell. However, none of the file systems that we're interested in have been mounted. This is where you need to use tools like fdisk to help you out. fdisk-l returns the connected hard drives and partitions. As you recall, or may or may not recall, we mentioned that SDA2 contains the root file system. So if we make or simulate what the rescue environment would do, so we'll make directory mount sysimage and then mount dev SDA2 to mount sysimage. This will mount if possible, and it has dev SDA2 to mount sysimage. We can then navigate to mount sysimage and interact with the file system. ETC is one of the directories, so let's navigate to ETC and LSL FSTab. There it is. We'll move it to simply FSTab and then reboot the system. You can always peruse the file to ensure that the file systems that are required are there, and then we'll reboot the system. So we've yet again rescued the system. We'll also ensure that the CD-ROM doesn't boot once the BIOS, the VMware BIOS screen is available. So we'll just move this down the list, and hard drive, so long as the hard drive's above it, we should have no trouble. And now we'll see the standard boot menu, and we'll be able to boot to run level number 3 with no trouble whatsoever. So hopefully you've gotten a sense for how to rectify problems related to Grub starting up. And this all, of course, supposes that you have no physical hard drive problems. These are just misconfigurations or perhaps attempted hacks or unauthorized access to your system. But we have no physical problems. So supposing there are misconfigurations that impact Grub or your file system table file, or if you've forgotten root's password, you now know how to make the changes necessary to get your system back up and running. You can always get your system up and running by booting the rescue environment. It will at least provide you access to a minimal shell in single user mode with tools such as fdisk. Many of the tools that you're accustomed to using, and these are of course shell-based tools, from run level 3 as well as 5 in a known terminal are available in the single user rescue mode, such as fdisk, ls, change root, so on and so forth. So we can use fdisk to enumerate the hard drives and partitions, mount them, get data off, and if you have network connectivity, you can even copy the data across the wire to a functional system. So we're up, running, back to run level number 3. All of our partitions are available, and we fixed or rectified any of the problems that we have encountered. So we'll move on to other things you need to know about Red Hat Enterprise Linux.